Hello children, today we are going to start our session with the techniques involved in organic chemistry. So far else we have discussed about the basic principles involved in chemistry, organic chemistry. Today let us start with our techniques. What are the techniques? Actually there are three different techniques involved in organic chemistry. One is the purification of organic compound, the other one is detection of elements in the organic compound, and the third one is estimation of the elements in a given organic compound. Okay, the first one is the purification techniques. Why do we purify the compound? We have to purify the compound, otherwise the impurities present in the compound may interfere its chemical properties and its general physical properties also. So the compound should always be free from impurities. So let us see the first technique, sublimation. This is useful for the purification of organic compounds which are actually sublime in nature. So the impurities present in it which might be a non-sublimable impurities. So during the sublimation process, the vapors of organic compounds will be collected and leaving behind the non-sublimable impurities. So by this method we can able to purify the compounds like naphthalene, benzoic acid, camphor, etc. And these are some inorganic substances like iodine, ammonium chloride, sulfur. They can also undergo sublimation process. That means they will go to vapor phase on heating without going to liquid phase. The second method of purification technique is crystallization. Crystallization is a process in which the organic compound and the impurities, they may differ in their solubility for a given suitable solvent. So based on this, the impure compound is made to dissolve in a given solvent and it is being allowed to heat because the organic compounds are usually sparingly soluble at room temperature, but at high temperature it goes highly soluble. So it can be heated up. It is allowed to concentrate on heating. Once it reaches its saturation point, the solution is allowed to cool down. During this, the crystals of organic compounds will be separated out and on filtration, the impurities are being removed. Sometimes the organic compound which may soluble in one of the solvent in better way, but in sparingly soluble in another solvent. In such conditions, we have to take the mixture of solvent to dissolve the compound, the impure compound in a substance. Okay, and this process should be repeated to get a highly pure substance. So if any colors impart with the solution due to the presence of impurities, that can be removed by treating with the animal charcoal. The next method of purification is distillation. The distillation process actually involves the difference in boiling point of the organic compound and its impurities, or even if we have the mixture of organic compound, they have to differ in their boiling point to some extent. Okay. So there are four different methods involved. One is simple distillation, fractional distillation, steam distillation and distillation under reduced pressure. Let us see first of all the simple distillation. The simple distillation, it involves the separation of volatile organic compounds from non-volatile impurities, and the volatile liquid and the impurities must differ in their boiling points somewhat high. That means the difference in boiling point of the component should be greater than 30 Kelvin. Such compounds only can be taken for simple distillation process. And when they differ in their boiling point, upon heating, the one which has very low boiling point can go to vapor phase immediately, leaving behind the one which has high boiling point. And the process is actually carried out in the setup of having an RB flask. That RB flask is fitted with the thermometer and a condenser. In this RB flask only we will take that impure compound. On heating, the compound which has the lower boiling point, it gets into its vapor phase and the vapors is allowed to pass through the condenser. That condenser is a device which is allowed to cool the hot vapor. So, the condenser through which the water will be circulated. So, when the hot vapor enter into the condenser, the vapor gets condensed, that means cooled down, and the volatile liquid is collected in the flask. This is what the process that is involved in simple distillation. Example, what kind of compounds can be separated? See, the mixture of chloroform and aniline can easily be separated. Chloroform that has the temperature of 334 Kelvin and that of aniline is 457 Kelvin. You may find the difference in temperature is about more than 100 Kelvin. So, when the compounds have such large difference in their boiling point, that can be purified by taking simple distillation. So, the next method of distillation process is fractional distillation. Fractional distillation, in which the liquids must be differ in their boiling point of about 30 Kelvin only. So, as the boiling point difference is about 30 Kelvin, on heating the vapors of all the liquids that will go simultaneously and will be condensed as a mixture of liquid only. So, in order to separate the one from other, the round bottom flask is fitted with the thermometer, condenser along with the fractionating column. The fractionating column that provides a large surface area and it has different patterns also. So, when the vapors of the liquid is allowed to pass through the fractionating column, it goes in a zigzag manner by which it may able to loses its heat because of doing some work. So, the one with the low boiling point will be collected at the top of the fractionating column. Following that, the other one with the high boiling point enters into it as a vapor. So, when the descending liquid comes down, the ascending vapor, it transfers its heat to the descending liquid. Once again, it gets re-vaporized and it gets repeated in the fractionating column. Finally, the liquid with the low boiling point is collected at the top of the fractionating column and it is allowed to pass through the condenser and it is collected as the liquid form of the component. And similarly, the rest of the component, though it has more than 2 components, that could also be done by the same method. Okay. Another method of distillation process is steam distillation. This method is used to separate the compounds which are steam volatile but immiscible with water. Immiscible means it does not mix with water, it makes a separate layer. That means water and organic compound will be separated by a layer, but their boiling points very close to each other. So, the compound, the organic compound can be vaporized at the steam temperature of water, that means about 373 Kelvin. So, because of this we may say the organic compound that can go to vapor form before it reaches its boiling point. So, let us see what is the technique involved in it. See that the steam from the steam generator is allowed to enter into the RB flask. That RB flask is already heated up and which contains that impure liquid. So, when the steam enters into it, the steam that mixes with the vapors of organic compound and it gets condensed into the mixture as water organic compound mixture. We know that the boiling point is reached when the atmospheric pressure becomes equal to the total vapor pressure of the mixture. Let us consider the vapor pressure of the liquid be P1 and that of water is P2. We know that the P1, P2 when it is equal to 1 atmospheric pressure, then only the boiling will start. So, as the sum of the P1, P2 becomes equal to atmospheric pressure, we may say that the boiling point, that is the vapor pressure due to organic compound is less than atmospheric pressure and hence the organic compound that can vaporizes at its lower temperature before it reaches its boiling point. And by this technique we can able to isolate the mixture of aniline and water. Next to steam distillation, let us take distillation under reduced pressure. This is suitable for the compounds having high boiling point, but when it is heated to its boiling point, the compound that may undergo decomposition, it won't be stable at its boiling point. Such compounds can only be purified by this technique. For example, glycerol. Glycerol is a major byproduct in the soap industry. Manufacture of soaps, the glycerol is obtained as the byproduct. So from the soap industry, glycerol is isolated from the soap by this technique only. So in this technique we have to reduce the pressure. When the pressure decreases, boiling point of the substance also decreases, because pressure is directly proportional to temperature. So that pressure that can be reduced from the surface of the liquid by using either the water pump or using the vacuum pump. So the liquid that can be allowed to boil at its lower temperature than its actual boiling point. After the distillation process, we have the next method, solvent extraction, in which we should take a separating funnel. Separating funnel is nothing but a flask having a long stem, and it would have a stopper over the top of the funnel, and the long stem and the flask will be connected with one more stopper, the knob. It is useful to close and open. So the one which is to be separated out is taken in the separating funnel. Actually, the components of the mixture would not mix thoroughly. After shaking the mixture on rest, it can be easily separated into two different layers. The one layer becomes organic layer and the other one becomes aqueous layer. Suppose if the solvent is water. So the one which has high density will be collected at the bottom, and the one with the less density will be collected at the top. Suppose if we have an aqueous and organic layer, water is high denser liquid, so will be collected at the bottom, and above the aqueous layer we may find the organic layer. And this method is very much useful where the organic compound is sparingly soluble in a given solvent and it requires more solvent to dissolve in it. In such cases, we can make use of this method. So upon shaking, that compound can easily be able to dissolve in the another layer, and by repeating the same process, it can be allowed to get the more soluble substance. The next technique for the purification of organic compound is chromatography. This method is not only useful for the purification of compounds, this is also useful to identify or to test the purity of organic compound. Actually, this technique is used to isolate the coloring matter in botany. Later on, based on the difference in adsorption of that component, we are using this technique to purify the organic compounds also. So in this technique is purely based on adsorption technique. Adsorption means the matter that can be adsorbed only on the surface of the other one. So we have the two different phases, one is stationary phase and the other one is mobile phase or moving phase. The stationary phase is actually containing an adsorbent. The adsorbent is usually either solid form of silica gel or alumina, or it could also be a liquid. And the mobile phase is nothing but the compounds to be separated or the purified is taken in a solvent and it is allowed to pass through the stationary phase, where the different components have the different types of adsorption. That means the way they interact with the stationary phase, they will be collected at the different zones of stationary phase. For example, if I consider the column chromatography, the column chromatography is nothing but a tube like a burette in which the pack of alumina or silica gel is taken. Before taking the one, the burette is filled with some cotton wool or the glass wool at the bottom of it. After that, the pack of silica or alumina is added into the burette. Then later on, the mixture of organic compounds to be separated out is dissolved in a suitable solvent and it is allowed to pass through the column, where the different components have the different interaction with the stationary phase of alumina or the silica. Suppose if the interaction between the substance and the stationary phase is very strong, that will slow very slowly, that will move very slowly. But the other one which has a very less interaction with the stationary phase, that can move very fastly. So the one which has very less interaction with the stationary phase will be collected at the bottom of the column, and the other one which has strong interaction with the stationary phase will be collected at the top of the one. and by using a suitable solvent, the different zones which have collected the organic compound can be separated out. This thin layer chromatography is also based on the technique of adsorption. It has two different types. The techniques involved in chromatography is adsorption chromatography and partition chromatography. The first one what we discussed, column chromatography, is also part of adsorption chromatography, and thin layer is also the part of adsorption chromatography. So, in the thin layer chromatography, the difference of taking the adsorbent is over a glass plate. But in the column chromatography, we packed that adsorbent in a column. But here the surface of the glass plate is coated with the solid substance of either silica gel or alumina, and the plate is immersed in the solvent, and the plate is taken with a baseline. It must be just above the surface of the solvent, and then over the baseline the sample to be isolated is kept at a spot. So this is called a sample spot. So once the plate is dipped into the solvent will start rise into the plate through the adsorption of alumina or the silica gel. When it ascends up the plate, the different mixture present in the spot which can be collected at the different places, and each places that is distinguished by its different color, and later on the collected matter can be removed off by using the suitable eluent. Retention factor is nothing but the ratio of the distance moved by the substance from the baseline, that is taken by the letter X, and the distance moved by the solvent, that is taken as Y. This is what the line that makes up to which the solvent has moved in the plate. That's why. So we can write distance moved by the substance from the baseline divided by distance moved by the solvent from the baseline, that is given by RF. The last chromatographic technique is paper chromatography. The paper chromatography that follows partition chromatographic techniques. In this case, that mixture is allowed to undergo continuous differential partitioning of different components of a mixture between the stationary phase and the mobile phases. The stationary phase actually a liquid phase, and the mobile phase nothing but it contains the solvent or a mixture of solvents in which the compounds to be separated out is taken. So just like thin layer chromatography, here also we are going to take a thin strip of paper. In thin layer chromatography we have taken the glass over which the solid material is coated. But in this case, we are going to take the paper as a special kind of paper is called chromatography paper. Chromatography paper in which the water molecule gets trapped into it. So the chromatography paper, it has a liquid phase of water, and when the paper is allowed to dip in a solvent or a mixture of solvent, sometimes single solvent can be used, sometimes they can make use of a mixture of solvent, depends on the kind of substances to be separated out, and the paper is made with the baseline. The baseline should always be above just about 2 cm from the solvent level, and when the paper is placed inside the liquid, the solvent it just gets arising up. When it arises up through the paper, the different components of the mixture is also collected and it gets evolved at the different parts of the paper. And from the color of the collecting the material, we can identify the components of the mixture is separated and it gets partitioned from one to another. And from this also you can find out what is retention factor RF. RF is nothing but the ratio of X to Y, where X is nothing but the substance moved from the baseline from the mixture to the distance moved by the solvent. So in this case, highly purified organic compounds can be separated out. So that's all. These are the various techniques by which the organic compounds can be purified. So the next class, let us see with the next session in which we will go and find about detection and estimation of the compounds. Okay, let us see in our next class. Until then, bye bye.